So let's explore these two kinds of database management systems, and let's start with the SQL databases, with relational database management systems. Now, how do SQL databases work? What's the idea behind them? Now, in SQL databases, you typically store so-called normalized data across multiple tables. Now, I'll come back to what normalized data means. For the moment, let me give you an example. Let's say we're building a website where we need airports and flights between those airports. If we opt for a SQL database, we could create two tables in that database, one for the airports and one for the flights. And then in every table, we would have columns and rows. For airports, we could have 3 columns with the ID of the airport, the city, and the country. We could also have more columns. You can have as many columns as you want. Now for flights, we could also have 3 columns. We could also have more or less. You don't need to have the same amount of columns in the 2 tables because the 2 tables will be totally independent from each other. And then in flights, we also might have IDs for the flights. And then we have our start and destination airports where we pick up the IDs from our airports. And that's important. We kind of relate these 2 tables with each other by using the ID from one table as a value in another column in another table. So the IDs of our airports, like JFK, are used in the start and destination fields of our flights table. And that's a very common thing to do in SQL databases. Now the data here is normalized because we don't have any nested data in any table. Every column in our tables holds only one value per row. Start does not hold 2 airports, but just 1 airport. City in our airports table does not hold multiple cities, but 1 city. And therefore here in this example, we would have normalized data split across multiple tables. Now you would create such tables in your database with help of some database management software or by running such SQL queries. And then the database would store that data and the schema of these tables in some files on your system, but it would do that for you. You are not involved in that file storing. You don't have to care about that. You instead would only interact with your database and with those tables. Now, one important thing to understand about SQL databases is therefore indeed that you do have clearly defined schemas and also data types. Before you start saving or fetching any data, you set up your database tables and you come up with a schema for every table and you define which kind of data should be stored in every field of that database. For example, that the ID of the airports should be some unique string, that city and country hold some text data and therefore strings, that the IDs of our flights could be integers that should be unique, and that we then again have more strings in there. The uniqueness is also an important feature here because that ensures that each row has a unique identifier, which is another very important thing in relational databases since you need to be able to establish relations between tables with help of such unique identifiers. Without unique identifiers, you could not have clear relations between different pieces of data in different tables. And that brings us to the next point. With SQL databases, you can of course then query your data and especially also your related data. You could, for example, run a simple query where you get all the flights that start in Munich. And you could then go to the flights table and query on the start column and search for the MUC identifier and get all the entries where you have that identifier. And then you could return the start value and the ID and destination value that belongs to this identifier. This would be a relatively simple query. You can also run queries across multiple tables, and indeed that's one of the main ideas behind relational databases. You can, for example, get all the flights data where flights start in Munich, but then you don't just want to get the flights data, but also all the data for that start airport. So then you would use that relation and that unique identifier, which is so important as I mentioned, to then also go to the airports table, look for the MUC identifier there in the ID column, and fetch all the data related to that airport. And then one query could return data about the flight, so the ID, start, and destination, and also in the same query, data about the starting airport, like the city and the country. That's the idea behind SQL. And of course, it still might be a bit abstract with these slides only, but in the very next section, we are going to dive deeper into SQL databases, and then we're going to play with some concrete examples in a real database, and then this will definitely become very clear. So these were SQL databases. And the key characteristics really are that you have multiple tables, possibly a lot of tables, and that you split your data across these tables, that every table has a clearly defined schema with clearly defined data types for the different fields, and that you can then run queries on a single table or on multiple tables by using these relations, which under the hood utilize unique identifiers which you have in every table.